Okay, with that, we are jumping into the Onyx Solar Group's Building Integrated PV section in Diego Cuevas. Thank you so much for making time for us, Diego. I realize that you are a busy person because you're running all over the globe.
Somehow, thank you so much for having me. It's a pleasure to be here and to be, well, participating in this interesting forum.
Well, thanks so much for being here. This is, if you didn't know, this is one of the places that we talk in California about how to decarbonize everything. So you're getting to see, you know, our policymakers and our leading architects and everyone else. Hopefully some of them might end up being customers for your really fascinating products. So with that, let me turn this over to you and you can introduce yourself and explain, you know, broadly what it looks like to start integrating solar panels into unconventional places like your business is.
Sure, of course. Yeah. So again, thank you so much. And well, I'm Diego. I'm the Vice President of Business Development for Onyx Solar here in North America. And we've been here with Onyx since 2011, 2012, 12 more or less. Well, actively promoting PV glass in buildings, which is not an easy task because there's a lot of things to do and to teach the construction community, the real estate developers, and the architects responsible for the design of the buildings that surround us. And well, just to give you a very quick overview about the company, if we go to the next slide, I'm going to talk to you today briefly because I have a lot of slides here about, well, Onyx Solar itself, where we are and what we do. What's a PV glass, a really simple concept for you to keep in mind. A little bit of cost information and analysis of the payback time and how the PV glass can help your building, well, bring a lot of, well, income yields and also help with the carbon footprint. And also we are going to have time, I believe, for questions and answers. So if we go to the following slide. Well, so next again. So regarding Onyx Solar, well, so we are a company originally from Spain. We are headquartered in Avila, which is 100 kilometers northwest from Madrid. So we are a privately held company with venture capital on board. And well, our fabrication plant is located also in Avila. Our headquarters with the most part of the technical department is there as well. We have a production capacity of 1 million up to 2.5 million square feet per year. And that's going to depend basically on the type of glass product that we manufacture. If it's thicker, thinner, larger, smaller, one design, another. So that's going to be the range. And then we work with two technologies, solar technologies. One it's called the AMORPHOUS silicon glass, and the other one it's called the crystalline silicon solar cells. So next. Okay, so in our factory, what we do besides fabricating the PV glass with these two technologies, we invest a lot of efforts in R&D. So we have a R&D in-house team from where we try to partner with the European Commission, with technological centers, with universities, to come up with new solutions, new technologies to apply to the glass and to be able to use them for the building envelope, and just try to come up with, well, new ideas, right, that we try to scale and afterwards commercialize and create like reliable products for the design community to use them, to install them, and actually to make the most out of them. So we can go to the next one. So basically, I'm going to give you an overview of what's a PV glass, right? So this is actually an image of a PV glass, which looks pretty much a normal glass, right? We can go to the next slide. So PV glass is, in general, it's an architectural glass that besides providing you the building with the same passive properties as a conventional glass, it's going to also generate free electricity for the building. So it's going to be the only building material that it's going to pay off, right? That it's going to offer you a return on the investment based on the electricity that it's going to generate for a course of 30 to 35 years. So next. So the main PV glass properties, it's first of all, obviously the energy generation. So it's going to help decreasing operations and maintenance costs for any building. And also it's going to decrease the CO2 emissions. It's going to filter UV and IR radiation, up to 99% of the UV and up to 95% of the infrared radiation responsible for the heat buildup. So it's going to be a high performing coating per se, okay? It offers also thermal and sound insulation. We can go as low as 0.13 BTUs for any particular project. So that's going to be normally dictated by the architectural team and the design and well, the energy efficiency goals for the project. Then it offers also natural illumination, so we can go or offer you the visible light transmission on demand. So depending on whether you want more light transmission or less light transmission, we can adjust the design of the glass and create like different options for you. And then obviously it offers innovation in design, right? So we are setting us apart from the traditional PV panel industry, not only offering the market a very reliable and efficient PV glass, but also it's innovative, it's aesthetically pleasant, and it's a new way to incorporate solar energy within the building envelope in a distributed generation manner, let's say. Next. So PV glass basically works as a revenue accelerator. So first of all, it helps decreasing the size and usage of HVAC equipment for any building in particular. It also helps unlocking tax credits and incentives. This is pretty interesting, especially for private projects in the country, right? Right now, we still have the 30% ITC, the solar investment tax credit, that it's granted for, well, at federal level for private projects. And well, that's going to make a huge difference in any project, because you can get advantage of that credit, not only in the amount of the cost of the PV glass, but also its installation, right? So it may make a huge difference for any project. And also then we have like performance-based incentives and well, like the accelerated depreciation as well at federal level. So there's a number of incentives that you would then be able to get otherwise, right? So it produces free and clean electricity from the sun. So you're going to basically lock the price of the electricity for the next 30 or 35 years. So that makes a huge difference as well, because you know what you're going to be paying for the electricity generated for the next 35 years. And then it's going to pose a positive contribution to the natural environment, because it's going to help decreasing the carbon footprint. Next. So what's a PV glass made of? So the PV glass is made of glass slides, obviously. We have also the solar cells, the inner layers, the junction boxes, and add-ons. And we're going to go over all of them. So in the next one, we are going to see, well, the glass slides. So the glass slides, there's no special requirement for well, this part of the product, right? So normally this is going to be dictated or like specified by the architectural team. And we can work with any type of heat treatment for the glass, so heat strengthened glass, fully tempered glass, or heat soak tested glass. For those listening who are not familiar with the glass and heat treatments, basically these treatments are going to help you, well, increase the strength of the glass under different temperature ranges, and to be able to be or to be used as a safety product, right? So for overhead glass, for curtain walls, skylights. So any part of the building envelope itself. And then we can use also any type of coating with the PV glass. So we can do low-E coatings, which are very popular right now in the industry. We can do also anti-reflective coatings, and we can do also hydrophobic coatings. So next slide, please. Well,
we just had a question here from Anne, who's an author of a Zero Energy book. She wanted to know, what's the life expectancy of the glass?
Yeah, well, so it's going to be generating power for at least 30 to 35 years. So it's a really long lifespan for the PV glass. So it's not different compared to a traditional PV panel, because basically the solar cell material is going to be the same one that you find in traditional PV panels. So there's no difference. So it's going to be 30 to 35 years.
And is the glass recyclable at the end?
Yes, of course. I mean, you can recycle it as any other glass product. But in any case, that's going to be a decision that you're going to have to make, well, based on the status of your facade or the skylight, right? Because many applications or products for the building envelope, they last even longer than 30 or 35 years. So even though the PV glass after 35 years is going to stop producing power, the glass is still it isolates the building, so you still have the thermal insulation, the sound insulation, so you don't have a requirement to change that envelope again unless you want to generate again power, right? But who knows what's going to be out there in 30 years time from now. So it's just well, as the standard offered by the industry right now.
Thank you.
Sure. So then, well, we were mentioning the low E coating, which is really popular here, and that's fully compatible with the PV glass. Actually, what it's going to do, it's a thin layer that it's spatter into the glass, and it's going to help isolating, well, the building better, right? So it decreases the heat transfer from the exterior to the interior and vice versa, okay? So if we go to the following one, next one. Yep. So then in terms of solar cells, right now we mainly commercialize two technologies, okay? One it's called a thin film, amorphous silicon glass, and the other one it's called the crystalline silicon solar cells. The crystalline silicon solar cells, these are the typical ones that you find in traditional PV panels, and you typically find the mono or polycrystalline solar cells. And the efficiency ranges for the PV module, it's going to be from 13 up to 20%, depending on the, well, the light transmission and the type of solar cell that we use and so on, right? And then the thin film, it's a amorphous silicon glass, and the efficiency ranges from 5 to 10%. So next. Okay, so then basically we have to create a safety product, what we have to do is to put two panes of glass together, right? So they are going to stick together, and in the event that the glass breaks, it won't vacate the space or the opening. So to do that, we have different products. They are pre-standard also for the glass industry. So we have PPB, we have Centric Glass, we have Vanciva to provide colors, we have EVA, and also different UV and chemical curable resins. So through a process of heat and pressure, we are going to put one of those layers in between the two pieces of glass, and in the laminator, it's going to kind of melt, and it's going to put together or stick together the two pieces of glass, so creating a safety glazing product. And the solar cells are going to be in the middle. Next. So then the specific, well, or different item for the PV glass is the junction box, right? Because this is something that you don't find in a traditional glass product. So obviously the glass generates power, and you need to extract that power, that electricity or that current from the glass out of the glass, and take it into a system, electrical system, and take it down to the electrical room in the building, right? So this little tiny device, it can be sitting on the rear part of the glass, or we can put it into the edge of the glass. Okay, so depending on the design of the framing system and whether you want to have it visible or not, we are going to go with one option or another. So one is called the rear connection junction box, and the other one is called the edge connection junction box. And next one. So here you can see a detail, right? So on the top left side of this image, you have the rear connection junction box. So as you can see, it's a little tiny device. It's about like 2.5 inches by 1.5 inches. And you see how the wire, because out of that junction box, you are going to have two wires, okay? One positive and one negative. And they are going to come with connectors. They are MC4 connectors. So it's going to be a plug and play system similar to what you find in traditional PV panels. So for example, with the rear connection on this image, you can see that the wire, runs inside the mullion system, inside the framing system. So you are not going to get to see that piece of the installation, right? So you're going to get a cleaner installation as well. And in the case of the bottom left side of this image, you have also the edge connection junction box. So as you can see, it's sitting on the edge of the glass, and well, it comes with the 2 wires, one positive, one negative. It's the size of a ball pen, more or less, so it's something really tiny. And this is the typical system that glazing contractors would prefer if they want to hide completely all the electrical interconnection and the junction box, so you can conceal it completely within the framing system. So it's gonna look like really aesthetically pleasant, okay? And then on the right, you have the image of the connectors, the positive connector, negative connector, and it's gonna be a plug and play system, MC4 connectors. And next. And then, well, we have what we call the add-ons, right? So the add-ons, basically, it's well, it's a previous one, please. Yeah. By add-ons, we mean anything behind the PV glass layers. Okay, so buildings, obviously, they require for insulation. And for insulation, we need to provide like double glazing units, triple glazing, so meaning spacers, argon spacers, air spacers, double glazing, triple glazing, you name it, right? So that's going to be dictated by the architectural or the design team. So we can build the glass from behind the solar cells down to the interior of the building. We can add as many layers as you may need of glass and coatings and treatments just to improve the performance of the glass itself according to the design. So that's what we call the add-ons. And that's going to be pretty similar and standard to conventional glass products. Next. Okay, so here we are going to compare visually, and we are going to go through some examples, both technologies that we offer right now. The fact that we offer right now 2 technologies is because they are really robust and they offer long-term stability. They are like economically feasible, actually really, really affordable when you do the math comparing to traditional or conventional glass. And the efficiency ranges is pretty good, actually. So we work, as I said before, we also do organic PVs, and under the R&D projects that we are involved together with the European Commission, the European Union programs, we are working on 3rd generation PV as well, but it's not yet ready for the market. So it's especially for the construction industry, it's still a few years away from commercialization states. But right now, amorphous silicon and crystalline silicon, they are really, really well, good options for you. So next slide, please. So the amorphous silicon glass. So first of all, I would like to well, show you or address this point because it's important, because many people get confused, right? So amorphous silicon glass is not a film. A thin film is not a film that we apply in between 2 panes of glass. It's a coating. Okay, it's a coating that we do through chemical vapor deposition. Okay, and we can achieve different light transmission levels. So we can start at fully dark, opaque glass that we would use for spandrel or non-vision areas. And we can go up to 10, 20, and 30% light transmission levels. So then the efficiency ratings from 5 to 10%. And well, the important thing or the best point of this technology is that, first of all, it looks transparent for the vision options. Okay, so it looks like a fluted glass. And when you keep a certain distance, your eye doesn't pick those lines, so it looks completely transparent. Okay. And then it harvests from diffuse light. So if you have a cloudy day, shadows projected, overcast conditions, things like that, this technology is going to keep producing power. Obviously, it's going to do it at a lower rate compared to crystalline silicon solar cells, but still, it's really interesting for west elevations, east elevations, vertical applications as well. So for those projects where you don't have like optimal orientations and tilts towards the sunlight, this could be a good solution for you. And it offers unobstructed views. Okay, so the next one. So here you have the traditional crystalline silicon glass. Okay, so in this case, we work again with the mono and polycrystalline silicon solar cells. They are typically 5 or 6 inches solid square solar cells. We mainly work with 6 inches solar cells. Efficiency goes from 13 up to 20%, depending on the type of solar cell that we use. And well, the main advantage of this technology is that under direct sunlight, so under a sunny day and well, with a good exposure, this technology is going to generate normally like twice as much as the amorphous silicon glass. So it all depends or comes down to what your goals are, right? So what's your like aesthetic like intent, okay, for the product or the project, and what's the energy generation that you're expecting for the building. So some architects or clients, they go after the crystallines, some others go after the amorphous. So there's different reasonings behind going for one and another, but in both cases, it could be really like interesting solutions for many projects. So next one, please. So we can do anything in terms of size, shapes, and colors, right? So we can manufacture the largest PV glass in the market, which is 14 feet by 7 feet. And well, we can do colors as well. So you can send us a RAW or a Pantone reference, and we will be happy to match that color for your project as well. So we have really a lot of flexibility in design. Next one, please. Yes, so we have standard dimensions, and we have also, well, customized dimensions. Whenever you can stick to one of our standard dimensions that you can see here in the presentation that goes up to 96 inches by 49 inches, the glass is going to be more affordable. Obviously, because the production process gets optimized, we have less waste, and we can, well, pass to the customer with better pricing, right? But other than that, most part of our projects, they go with customized dimensions, and well, they are going to cost a little bit more per square foot, but it's still really, really affordable compared to probably what you think the glass would cost. So next one, please. So in the case of the crystalline silicon technology, it's going to be the same thing, right? So here we have well, standard dimensions. We can do also customized dimensions. And as you can see here in this slide, in particular, we can do shapes, right? So you can see a triangular PV glass and also a hexagon that we installed actually at the Denver Botanic Gardens a few years ago, and it's a fully functional PV glass. So as you can see, it's all about laying out the solar cells. And basically, the light transmission with the crystalline silicon solar cells, it can be adjusted depending on the layout of those solar cells. So we can put them all together. So we are going to have more solar cells per glass unit. So we are going to have more power, okay, but less transmission, light transmission. If you want more light transmission, we are going to keep greater spaces in between the solar cells. So we let the light to pass through those gaps, and well, we decrease the power output, but we get more daylighting. Okay, so that's a compromise or a trade-off between the light transmission and the energy generation for the system. But in any case, that's something to be discussed with the design team as well. Next. So here, I would like to show you some applications, and then we can jump also into some, well, price information, because I'm seeing some questions here that people is really looking forward to get pricing information, and I'm going to be happy to share with you all those details as well. So if we go to the following slide, please. So this is, for example, a PV skylight. Okay, this was installed back in 2012 for Novartis Pharmaceutical headquarters in New Jersey. This is a project designed by Rafael Vignoli Architects, and here what we created, it was a PV glass made of crystalline silicon solar cells. And well, the goal here was to look for the right balance between diffuse light, because this is an office building, and also the energy generation. So in this case, we used a very special solar cell that had holes on it, like drills, to allow for the light transmission to pass through, despite it's a crystalline silicon solar cell. So it avoids the emission of 182 tons of CO2 per year. And well, this was actually awarded the best regional project of 2012 by Engineering News Record McGraw-Hill Construction in the state of New York. Next one. Well, as you can see in this image, this is the same project. So it's a 207, well, yeah, perfect. It's a 272 kilowatt system DC. It generates approximately 308,000 kWh per year. And the glass in this case, it was pretty large. So as you can see, like 7 by 2.5 feet. So as you can see in the zooming on the top part of this picture, you see that solar cell that I mentioned with the drills on its surface, just to allow for more daylighting inside the building in a diffuse manner, which was really important. Next. So this is the performance of the system. Actually, we are monitoring it in real time. Actually, well, the system has been up and running for a few years now. And PV system, PV watts, well, the reports created by the utility in New Jersey, they stated that the system would generate at least 276,000 kWh per year. And as you can see, we have been every year overperforming. Okay, year one, it was 32,000 kWh per year. Year two, 310. Year three, 322,000. So all the way down to year five that we monitor the performance in real time from the computer, right? As you can see here, there's a decrease, right? So the year one, it generated 332,000 kWh per year. And the year five, it was 294. So the difference is not just that, or you may think that it's not performing as well as year one. The reason behind this energy generation drop, it was because in the East Coast, if you recall, for those who live here in the East Coast, the winter was especially severe, right? So we had a lot of snow, and the snow was sitting on top of the PV skylight for a long time, so it decreased the energy generation for the system. But in any case, again, always over the expected amount calculated by the utility, right? And this was partially because of, on one hand, the high quality of the raw glass lights that we used, and also the smart electrical design that the electrical contractor created for the project. Next one, please.
I just want to give you your 3-minute warning, just so you know.
Oh, okay, I'm gonna try to to speed up. So this is another example. This is the Bellworks project in Homedale, New Jersey. It's a 60,000 square feet skylight. In this case, this is with amorphous silicon glass. So this is the old picture when all the glass was, well, the skylight was leaking, the glass was broken, and we renovated it with amorphous silicon glass. If we go to the next one. This is, well, the first bay that they install as a mock-up system. You can see the little squares are the junction boxes. So you can tell the transparency of the glass, right? Next one. Yeah, so this is the final result. So this is one of the sections of 20,000 square feet of glass. So there's 3 sections like this. And as you can see, it provides tons of natural light. It blends really nice with the architecture of the building. And it's a glass that it's generating power. The good thing about this project is that this was more or less a $3 million project, okay? And thanks to the tax credits, the owner got a 1 million back in credits because they did a sale leaseback operation. So they went cheaper for them to do the PV glass versus conventional low-E glass. Next one, please. So this is the picture from a night view. Next one. I'm just trying to speed up to show you because we have a lot of images and they are beautiful. So this is the skylight again. Next one. This is another skylight with amorphous silicon glass, 20% visible light transmission. You don't get to see wires, junction boxes, because everything is concealed within the framing system. It's in Madrid, in Spain, San Antonio market. Next one, please. This is another skylight, 10, 20, and 30% visible light transmission combined, inspiring Piet Mondrian. It's another skylight in Spain, and here, well, it's another nice way to combine the amorphous silicon glass technology with different light transmission levels. Next one, please. So this is the Denver Botanic Gardens, the Pyramid Science building. As you can see, the dark hexagons are PV glass, the one that I showed you before, fully functional, UL listed. So a really nice product that demonstrate how flexible we are in terms of the product design. Next one, please. This is another vertical facade, a RAINSCREEN cladding system for Pfizer, the pharmaceutical company, with amorphous silicon glass. Next one, please. Just running through the slides to show you everything. So this is another second skin facade with amorphous silicon glass for a project in Turkey. In this case, a 20% visible light transmission glass. If you go to the following slide, you're going to see how beautiful it looks and how it blends with the architecture of the building. So as you can see, wow, who would tell that this is a PV glass that generates power for the building, right? So they have a TV on the lobby that monitors on real time the energy production by the facade. And they explain how sustainable they are becoming, because also they have traditional PV panels on the roof that no one can see, right? So you lose a little bit of that PR effect and the sustainability awareness creation. Next one, please. So these are PV fins designed by Perkins and Will for the University of Washington. This is a project that we completed last year. So these are vertical fins that go perpendicular to the curtain wall. So they provide shading, and at the same time, they generate power for the building. Next one, please. So you can see here a close-up picture of that fin in our factory. And when you see them from the distance, they get completely transparent. Next one, please. So these are PV fins with colors as well. This is a project that we did for DEWA, the Water and Energy Authority in Dubai. And this is a glass that surrounds the whole building with different colors, and it's a amorphous silicon glass as well. Next one, please. Next one, please. Same project. So this is, for example, the Miami Heat Arena, the American Airlines Arena, home of the Miami Heat in downtown Miami. So here we install with the Skanska 16 circular skylights with the crystalline silicon glass, and we include LED lighting that change color depending on the venue that they are hosting. So it's a nice way also to generate power. Next one, please. So this is the Bay Area Rapid Transit Station in Union City in California. It's just 20 minutes away from Embarcadero. So it's a standard canopy with crystalline silicon solar cells on a very thick glass with a free pattern to improve the aesthetics from behind. It's actually the oldest installation that we have in the country. This is from 2011 and working really up and running for 8 years and working really well. Next one, please. So these are different designs that we can show with the PV glass. So we can do frieze, we can do acid etching, we can do colors. So it's a huge range of options. So we can create really beautiful products for buildings. Next one, please. So this is a canopy. Actually, it's the cover of a indoor swimming pool in a residential application in Tiburon in the Marin County. As you can see, you can get completely clear views. So you filter 99% of the UV radiation, 95% of the infrared radiation, and you enjoy the views, which is really important for this building owner because it's a high-end residential project. Next one, please.
Diego, we really should move to the next presentation. I try to keep it exactly to 30 minutes if I can. Was there anything else you'd want to share with us, particularly around how much they cost compared to?
Yes, if you can just keep going a little bit more, just to show you just two things. So this is a really nice curtain wall with the crystalline silicon solar cells in downtown Miami as well. And there
we go, cost, yes.
Yeah, so the cost, if you move one more. Yeah, so basically here we have a ballpark, right? And whoever wants this presentation, I can share it with you after this event. So basically for laminated glass, starting at 1/4 plus 1/4 fully tempered glass, we can start at $15 a square foot, okay? for the PV glass. Then if you need glass for coating walls or skylights, so with insulating properties, so double glazing or triple glazing, we start at $26 a square foot, and it may go up to $35 a square foot, depending on the design on the glass. The cost of the structural system, it's going to be the same or almost the same, because you don't need like a special systems. You can work with any like a standard system from Kaunir or Castle, YKK, so you name it. And then the cost of the electrical balance of system, which is the inverter, switches, protections, additional wiring, that tends to be in the range of $6 a square foot on average. So at the end of the day, it's going to be like a minimum, additional cost for all the benefits that you can get. Because there's, if you go one more, the next one, and another one, please, which is really another one, really the last one that I want to highlight here. Yeah, here. So this is a real case study that I'd be happy to share with you as well. So here we compare the return on the investment for a conventional Lowy glass replacement for a skylight. A monolithic glass versus conventional Lowy glass or amorphous silicon glass. So in this case, with conventional glass, they recoup the investment in year 22. With the PV glass, you recoup it in year 9.5. And that's because of all the incentives that you get, the 30% tax credit, the accelerated depreciation, the tax exemption, the SREX market, the energy production, and the energy savings. And this is all information that comes from the Department of Energy, desireusa.org. that gathers all the information on the incentives available, and we carry all these feasibility studies for free for our customers to evaluate whether or not it's going to be a good option for them to go with the PV glass or not. So I can share all this information. I don't want to take other people's time. So thank you so much. I'm sorry that I went beyond.
Yeah, this is just beautiful. I mean, just gorgeous. It's amazing.
Thank you so much.
No,
I'm sorry that I had to go really quick at the end. I see that I have a lot of questions here, like 12 questions, something like that. I would be happy to address them, I don't know, via email, or whoever wants to send me an email. I'm at usa@onyxsolar.com. That's the easy one, and I'll be happy to help you with
why don't you type it into the chat on the side?
Oh, sure.